Hi everyone, my name is Amy Priest. I'm a chemistry tutor here at REACH, and today I'm going to talk to you all a little bit about the difference between order and molecularity. You may have heard these terms. They're introduced in chapter 48 and 49, and a lot of students seem to get them mixed up, which that can be a real problem when you're trying to work through different types of book problems and true and false problems. So let's start with molecularity. Molecularity is introduced in chapter 48, and the book defines it as the number of particles that are reacting and undergoing a collision at any one time. So the key word here is reacting. For molecularity, you're only looking at your reactants. And your book tells you the highest amount of particles that can chemically react and collide at one time is 3. So you will never have a molecularity larger than 3. So let's take a look at a few examples. We have SOCl2 going to SO2 and Cl2. We have our reactant arrow. So over here are our products. These do not matter. These will not affect the molecularity. So looking at our reactants, notice we just have one molecule. So molecularity for this equation is 1. For our second equation, again, we don't need to look at our products at all. So looking at our reactants, we have one molecule of H2O2, so that counts as 1. We have 2 molecules of I-, so that counts as 2. And we have 2 molecules of H+, that's another 2. That gives us a total of 5. So you may be wondering, I just said you can't have more than 3 particles interacting in one step, and here we got a molecularity of 5. So what that tells us is that this step is not a single elementary step. A single elementary step will have a molecularity of 3 or less. So if it has a molecularity greater of 3, then you can tell that this equation must be for a composite mechanism, and you can read about those more in your book. So that's the quick version of what molecularity is. Just count up your reactants. If it's 3 or less, it can be an elementary step, and if it's more than 3, it has to be composite. So we're looking at order. Order is introduced in chapter 49, and order is all about rate. They give you the general form in your book of A to the F, B to the G. What this is saying is that A is in the order of F, and B is in the order of G. So looking at an example, here we have rate equals K. K is your rate coefficient of Cl2 to NO2 squared. So notice Cl2 does not have any type of exponent here. So a lot of students may say, okay, we have a molecularity of 0. That is not the case. Think of this as having a 1. So if you have no number, then that is in the order of 1. So for Cl2, our order is 1. For NO2, we have a 2, so its order is 2. So we can say this reaction is first order for Cl2. We can say this reaction is second order for NO2. Or we could say, if you could add up their orders, it equals 3, so it's a third order reaction overall. So why do you need to know the difference between these two terms? A lot of times it could be a true or false type question on an exam, or you may be asked how to, you may be given an equation and you may be asked how do you determine if this is a elementary step or composite step, and again that's where you look at molecularity. And then order becomes really, really important in chapter 49. 49 is all about rate laws and integrated rate laws and finding out how much of a reactant you have at a given time. And that's where you have to know order. So you need to know the difference of these terms to even be able to solve problems. So take a look in chapter 48 and 49, read through those examples, watch this video. Hopefully that will help. If you need more help, feel free to come see us at REACH. Our office is in Strickler 111, or you can find us online at reach1.louisville.edu. Thanks for watching.